Okay.
One of the classes I was looking at was only lectures on Monday. And it lasts like 2 weeks. Max.
That's gross.
It lasts like 2 months. It's not a whole semester. You have to retry it. For what? I mean, what class I'm gonna take.
Total mass of the solution involves the solute. When it comes to mass percentages, they need to be in the same units. So I converted the 13.5 to kilograms. And added it to the solution concentration. So I'm going to divide the two. Is that formula correct for mass percent? It's nod? Yeah? Doesn't matter what the unit is, they just have to be in the same units. Could you have converted the kilograms to grams? Heck yeah, you could have. Should get the same answer either way. What do you get when you do this? Oh, you're right. I'm sorry. My bad. Total mass of the solution, right? So that's solute plus solvent. You're right. 0.0135 divided by. So yeah, 11.9%. That's what I got. Yeah. Yeah. So we're gonna go through B next. I just wanted to make sure we got this. Hopefully we can follow this. Okay. All right, so B says, what is the molality? Is that correct? Or no, I'm sorry, parts per billion. Million. What is ppm if 2.5 gram sample of water has micrograms of... Okay, so what's the formula for ppm? So what goes on top? So mass of the solute in this case over the total mass times 10 to the 6th. Okay, so first things first, again, when we do any kind of manipulating here, they have to be in the same unit, right? So I'm going to convert this to grams because this is in grams. Okay. How many micrograms in a gram? Correct. So we're going to divide by 10 to the 6th. I got a really small number. Look right? 5 zeros. Okay, so then I'm going to do the total mass next. In the grand scheme of things, is that small concentration of the zinc ion going to matter in the total solution mass? It's not really going to impact things much, but we should still keep it around for posterity's sake. Okay, what's our next step? Set it up. Okay, so we're going to put our small number on top. We're going to put our total mass on bottom. We're going to multiply times 10 to the 6th. I got that. Is that what you got? Good. Let's see the practices. You want to do another one? So the first one is to calculate a mass percent. And it looks pretty straightforward because it's got grams and grams, so you don't even have to convert anything in that first one. The second one has you using the mass percent to calculate the mass of A. So plug what you know into the formula to find out what the mass of the NaOCl is. So do A and B for me in the practice exercise. So if you're following along on your computer, it's on the next page. I think it even gives you the answer. You're really interested. I'll show you the answer in a second, but I'd like you to at least do A. Try to set up B, and then we'll go through together. And this one doesn't give you like step-by-step procedure that you have to convert. You have to kind of make it yourself. It tells you what you're doing, and that's what it is. You're gonna have to come up with like the actions. Okay. Oh, we already have to with our partners. Yeah. Oh, yeah. So I'm gonna have to, yeah. You're under strict orders not to burn the place down. I said you're under strict orders not to burn the place down.
You were allowed to.
Hello, my lovely remote learners. In case you're wondering what we're working on the practice problems that are posted on Office 365. We've been working through exercise 13.3. Right now they're working on the practice exercise, and then I'm going to go through it. just thought you should know. I miss you all. One day. What? I'm talking to the remote learners. Huh? I'm talking to my remote learners. She's like, who are you talking to? I'm talking to my remote learners. No, I'm not conferencing. So if you're not here, you won't attend class live. You'll attend class after class.
I was like, why is she talking to the phone?
What? Thank you for
Sorry.
letting it go on as long as you did.
I didn't notice it until now.
Oh, yeah. What's up? Mm-hmm. Say again?
Does bleaching solution include the sodium hypochlorite?
Yes. So the 2.5 is the solution concentration. Yes. So it's the total mass. Did we get A? Yeah? What we get? Say again? You got 3%? 2.9-ish. Most of us got that number. So you did 1.5 over 50, right? Okay. For part B, you were given the 3.62% by mass of the NaOCl is going to be equal to, remember the whole formula, okay? So the mass of the NaOCl over the 2.50 kilograms. So when you calculate your mass in this particular case, it'll come out in what unit? Kilograms. And don't forget that when we do percentages, you have that times 100%. So you have to divide both sides by 100 to start. From there, you should be solving. Yes?
Does the 2.5 already include the...
Yes, because that's the 2.5 kilograms of the bleaching solution, which contains the NaOCl. It gave you the total mass on purpose. You couldn't calculate it if you didn't. You'd have too many variables if you didn't. What did we get? I got 0.0905. Is that right? And this is kilograms of NaOCl. Super right. Look at that. If I multiplied this times 1,000, would it become 90.5 grams? Yes, it would. And they gave us it in grams. But hopefully your answers match that. How are we feeling so far?
What was the answer for A?
A was 2.91%. See that? All right, so let's do some molarity calculations. So for molarity, what's the formula that we need?
Moles over liters.
Moles over liters. In this particular case, we're given 4.35 grams of glucose
It says calculate the molality.
Oh. I'd rather you do molarity, but you could do it. You could do both. Let's do molarity and molality. Well, it's confusing. It says calculation of molarity, and then it says calculate the molality, all right? Okay. So we're going to do molarity and we'll do molality. They're both pretty hand in hand. What's the formula for molality? Moles over kilograms. Remember, this is moles of A over kilograms or moles of A over liters. Remember that A represents the solute, and that some of these in solvent and others, depending on what we're trying to find. So in this guy, we're given the amount of glucose there is. We're told it's in 25.0 ml of H2O. For this one, we're given that water has a density of 1 gram per milliliter. Okay. All right, so what do we need to do first?
We're gonna make some.
I mean, none of these things have grams, so we're gonna have to convert to moles. So what's the molar mass of C6H12O6? 180.2. Yeah. So let's set it up. We're going to need the moles for each one. Guys, my honors chem kids are getting to the point where they don't need conversion factors anymore. It's really exciting for me. Yeah, because they don't have to write like 20 fractions when it comes to stoichiometry. You remember conversion factors and writing this both ways over and over and over again? Yeah, we're finally at the point where we don't have to write the conversion factors for some of them. I'm really excited about it. All right, so then we have this. What does it come out to be? I'm going to cheat and tell you what the slide says. Gives me 0.0241 moles. For molarity, we need liters. So how do we convert milliliters to liters? Divide by 1,000.
There's a lot going on.
It's only Tuesday. Okay, give her some
Okay. All right, so for molarity, we're going to take our molar amount, divide by our total solution volume. I'm getting a number very close to 1. So how we express that concentration is a capital M, or we can write out moles per liter. I don't care. I care that you know that this is a molarity and this is a molality. All right, for the molality, we need kilograms on the bottom of the solvent. In this particular case, we're given that the solvent has a density of 1 gram per milliliter. And if we know we started with 25 milliliters, to get it into grams, we're going to do 1 gram over 1 ml, because that's what the density is of the solution, which means we have 25 grams of the solution. Remember that for molality, is it kilograms of solvent on the bottom of the equation, or is it kilograms of the solution? I want you to look. I want you to look at your notes. Oh. Kilograms of solvent, right? So in this case, do we need to add the mass of the glucose to get the final solution mass? We do not. We just need to know the mass of the solvent in kilograms. So how do we go grams to kilograms? Divide by 1,000. Okay? We already have the moles, so all we have to do is take our moles, divide by the kilograms, and we're going to get the exact same thing. Now, one of the things to note about molality is a lot of times you will see it expressed as molal. You won't see like lowercase m. A lot of times that's to like avoid confusion with masses and things like that in your solutions. Okay? All right. For homework tonight, I want you to attempt your practice problem set, which is on OneNote. And I want you to read over the lab and come with questions about lab tomorrow. That's what we're going to do during second hour. Prep the lab. If you have questions, I'll answer them. Yes, ma'am.
What is that 0.024?
From the overall problem, because we were given the 4.35 grams of glucose, remember? The number of moles doesn't change if we're trying to calculate these concentrations.
Oh, okay.
We're doing
I
the
see.
same problem.
Okay.
Yeah.
Gotcha. Thank you.
Okay. We have time in class. Start that homework set, please.